Okay, so we're going to do another example of Descartes' rule of signs. Given this fifth degree polynomial, f of x, we want to find the number of possible positive and negative real zeros of f. Okay, so we're going to use Descartes' rule of signs. The first thing I need to do is I need to find the number of sign changes in f of x. And so I've got 1 here, positive to a negative. That's not 1. And then there's another. There's 2, and then now 3, and then 4. Okay? So let me double check that with my eyes here. So positive to negative, that's 1, 2, 3, and 4. Yeah. Okay, so the number of sign changes, I'm just going to put SC for short, number of sign changes in f of x is 4. Okay, so we got that number there in red, and that's going to give us what? The number of possible positive real zeros of f of x, right? Okay. Or the theorem says that or it's less than that number by an even number. Okay, so that means that now I need to take that 4 in red, and then now I need to subtract the even numbers from it, which are beginning with 2. And then 4 minus 2 is going to give us 2. Okay? Or, we've got another or. Okay? Or, the number of possible positive real zeros is going to now be what? It's going to be this 4 here minus 4, which is going to give us 0. Okay? So for this particular polynomial, it's possible that it has either 4 or 2 or 0 number of positive real zeros. Okay? All right. Now, if I did that one more time, notice if I do 4 in red minus 6, I'm going to get a negative, and that doesn't make sense. Okay? Now, we need to look at the number of sign changes in f of negative x. So f of negative x would be what? Negative x to the 5th minus 3x to the 4th plus 3x to the 3rd plus 6x squared plus 4x plus 1. Okay? So the number of sign changes is what? Just 1. Okay, so we're going from a negative to a negative. That's not a sign change. Negative to a positive, yes. And then positive to positive and positive to positive, that's not. Okay, so we see that the number of sign changes in f of negative x is, I'll use green. How's that? Just 1. Okay? So that green, number 1, is going to tell me what? It's going to tell me the number of possible negative real zeros of what? Of f of x, right? Remember that even though you're looking at the sign changes in f of negative x, it's always giving you information about the original function of interest, which was f of x. Okay, so now we've got what? The second part of the statement says, or it would be that 1 in green minus the even numbers. Well, again, now I have to subtract these even numbers here in blue, and that's negative, so that doesn't make any sense. Okay. Now we're going to build our chart, and so the chart, we're going to have to pair up every one of these red numbers with the green one down below. So 4 will pair up with 1, 2 with 1, and 0 with 1, which means that our chart is going to have 3 rows. Okay? So we're going to have 3 possible outcomes for this polynomial. Alright, so I'm going to abbreviate here, folks. I'm going to do number of positive real zeros. We've got number of negative real zeros. And then we've got our non-real. The number could have i's in it. Okay, so we said a moment ago we're going to have 3 rows. Okay, so now each of the red numbers, as we said already, the 4 will pair up with the 1 in green. Okay, that 2 in red will pair up with the 1. And I'm not going to keep going backwards and get dizzy. Okay, so 0 pairs up with 1. Okay, now those are your 3 possible outcomes. And since this is a 5th degree polynomial, if you have already accounted for 4 of them that are positive reals, 1 that is negative and real, that means that the last row will be 0, because you've already accounted for all 5. Okay, so again, each row has to add up to 5, which is the degree of your polynomial. Okay, 2 plus 1 is 3, so that means that there's got to be 2. So remember, they're coming in pairs because of the complex conjugate pairs theorem applies here. And if you've only got 1 0 that is real, then the other 4 must be complex. Okay? And this chart is going to help you when you actually go further and actually want to find out what those zeros of f of x are. Alright, I hope that helps you to review.